Hi all, this is a demo on how to set up and run WebMaxim, which is a simulator for evaluating inference performance in DRAM CNN accelerators. The setup of the simulator is pretty straightforward. We clone the repository, start the simulator, we execute .py file. So I have cloned this repository in my local, then I have opened it. I opened the same files and the same folder in IDE, Visual Studio Code. So the main.py file looks like this. So initially we give the list of CNN models, that we want to perform inference on. The available CNN models are provided in this folder. We can select any of these models or all the models in this folder to evaluate the performance of an accelerator. Then we provide the list of accelerators for which we want to run the simulations. The accelerator list takes the accelerator configurations. The configuration of these accelerators are provided in config.py file. The structure of the accelerator configuration, it is a dictionary where you provide different parameter values like the name of the accelerator, the number of parallel processing elements, the latency of multiplication, the latency associated with addition, data moment latency, and MAC energy, and also the data flow. So currently the accelerator can only map wait stationary data flow. However, it can be extended for input stationary and output stationary as well. And we also have the uh, option to provide an input batch size for execution. Then moving on to the main.py file. So the simulator first reads the accelerator configuration. Then it reads the model being executed. It reads the model layer by layer and it captures the information of a layer, several all the dimensions of the layer. Then it converts this convolution operation or fully connected operation into a gem operation. To understand how convolution operation can be converted into a gem operation, you can refer to the figure show convolution to gem.png. Here it illustrates how a convolution operation is transformed into a gem operation using Topli's matrix transformation for the input matrix and flattening and stacking of weights for the weight matrix. Now, once this transformation is done, the gem operation is mapped onto the available processing elements using the three loops shown over here. Depending on the loop order, the data flow will be changed. Here, the loop orders are defined for wait stationary data flow. Therefore, the weights are less frequently changed compared to inputs and outputs. At each layer, simulator captures various performance metrics like total latency, total data moment latency, total MAC energy, and some other values like utilized processing elements or idle processing elements. Then finally, once all the layers are finished for the model, the model the simulator logs this information into a file named acceleratorperformance.csv. The acceleratorperformance.csv contains all the information captured during the execution of CNN model on an accelerator. It captures total runtime, total data moment latency, total MAC energy, and bottleneck ratio. Now let me show how you can run the simulator. So just open the terminal, then you just run the command python main.py. It will run the simulations. It generally takes a while depending on the kind of PC you have, the configuration. So it logs some information to update the progress of simulations. Like it tells the data flow, accelerator architecture name, and the layer which it is processing. So once the execution is completed, you will see something like this. At the end, it will print the capture latency, data movement latency, MAC energy, and other metrics. All the latency values are shown in nanoseconds, and energy is reported in picojoules. So one other important thing is how did I arrive at these values? These values are provided in the C Excel sheet, which is attached in the repository, RTO paper results. So if you open this file, then inside the file you will find a sheet where it's named as final calculations. So I have taken the values from this sheet. So if you want to execute or test other accelerator, you need to create a configuration file for that particular accelerator using the information provided here. For example, if you want to test scope H2D, then we need to create a config file like this and just update it according to the scope parameters. We are trying to simulate scope, string elements, PRCSC, multiplication cycles are written just 20, efficient 4, 24, energy per MAC energy here. So now the configuration for scope to it. Now we just have to configure the accelerator to run, the simulator to run for this accelerator. So we update this accelerator list with H2D. Also, please note that you can also in a single run test multiple accelerators, which is each output line or each output row. So each row in the accelerator performance.csv we have the information in different accelerators. Yeah, that's a good works. The questions is reached out first.